Hello everyone, and I welcome all of you to this introductory session, and also welcome to all those who are going to watch this session later on YouTube and on other platforms. And I can see people joining from different parts of India, as well as I see people from joining from different parts of world also. So thank you for taking out time and attending this session. So this is an introductory session that we are conducting on a new online course that we are going to soon start on the topic of design and detailing of RCC tall buildings. So before I start, I hope my voice is properly audible and there is no issue with watching the video as well. Yes. Good. So let us begin then, and let us start with this introductory session. I'll be speaking for around 40-45 minutes with the session, and then we will have your queries or questions or whatever doubts you have regarding the session. You can ask. You can ask your questions in between also. If they are relevant, we will take them there and there itself. Otherwise, we will wait for the Q&A. Okay. So let's begin then. What is the agenda quickly? We will start by discussing what are tall buildings, how they are different from your regular buildings, what is happening in the Indian context right now, and we will talk about other countries also, but mainly what is happening in Indian context. Why did we think that such a course we should conduct on our platform? A few things about us, our evolution over the past 7-8 years, what impact we have been making or what impact we have created for our participants, those who have taken our sessions in the past. Then we will come to the details of this particular course. What are the details of this course that we are going to soon start? The features, who will benefit from the course, the expected course outcome, and then we will have your queries. Okay. So I'll be speaking for around, as I told you, for around 40-45 minutes, and then we will have your questions or discussions. So, what are tall buildings? So the term, you might have heard about this before. The term tall is actually relative. It's not an absolute term. Okay. So for example, if my let's say my height is 5'6" or 5'7" around, so I may be considered as a tall person if I am standing in a crowd who are, let's say, 5 feet tall or 4 feet tall, isn't it? So I am tall if I am standing in front of people who are shorter than me, or they are if I'm standing in front of young kids, let's say. But if I am standing in front of a person who is 6 foot or 6 feet plus, I am not tall. All right. So this concept of tall is actually relative. If you think in terms of height, let's say in a small town, or a small city or a small town, even a 20-story building may be considered as a tall building, isn't it? Where other buildings are, let's say, 4 or 5 stories, even a 20-story building may be a tall building. But if you go to any big cities, like if you go to a city like New York, or if you go to a city like Chicago, or if you go to, let's say, Mumbai, then even a 50-story building may not be tall enough, isn't it? So this term, when I say tall, it is relative if you think in terms of height as such. It also depends on the proportioning. What does that mean? That it depends on the aspect ratio. That means a building which is, just a minute, I'm just facing some issues with this pointer. Yeah. So a building which is, let's say, having an aspect ratio something like this. This may, I'm showing the elevation, of course. So this may give a feeling that it is tall. Why? Because it is slender, it is having a high aspect ratio. But if you see a similar building having a small aspect ratio, having a small aspect ratio, having equal heights, but maybe this building number two may not give you that sense of tallness if you compare it with building number one. Why? because this building number 2 is also having a very large plan footprint. Okay, so sometimes whether a building looks or feels tall can also be uh, can also depend on the relative proportioning of that building. Are you not able to see anything on screen? I just got a message on YouTube. Your screen is not visible. Arre, just a minute. Just a minute. Is it now visible? Oh, so last 5 minutes you're not able to see anything? Okay, okay, good, good. So I'll just repeat quickly what I was telling you. Sorry for this inconvenience. I'll just quickly repeat what we were discussing. We were just discussing that what are tall buildings. So first thing I told you that term tall is relative. Okay, this term tall buildings is a relative term. So if you think in terms of height, it depends on the adjoining structures. That means a 20-story building may be considered as a tall, where other buildings are, let's say, 1 story or a 2 story or 3 story, 5 story structures. Even a 20-story building may give you a sense of extreme tallness, isn't it? In other cases, if you go to any big city, I was telling you like New York, Chicago, even a 50-story building may not feel tall enough. Why? Because other buildings in the vicinity are 100 stories, 80 stories, 90 stories, and so on. So this term tall is a relative term. It cannot be, I mean, it is not an absolute term in itself. The second point I was trying to make is that the feel and effect of tallness also depends on the proportioning. Okay, so if you have a slender building which has a large aspect ratio, it may give you a feel and sense of being tall compared to a building which is having a low aspect ratio that may not look and feel tall enough. So it depends on the relative proportioning also. Okay. Uh, I hope this is clear. Yeah. I hope now the video is visible and you are able to see what I'm writing on the screen as well. Yeah. Okay. Good. Good. All right. Okay. Another, if you see another set of definitions or another set of understanding people have whether a building is considered as tall is whether or not any special system is being used in the building. What is the meaning of special systems? So you might have heard about some dampening systems to dampen the wind and seismic responses. So whether or not you are using any special systems, that may also sometimes decide whether your building is tall. Although I don't agree a lot with this particular definition as such, the most important and I would say relevant definition will be that usually we will call a building as tall when the lateral loads start to dominate over your gravity loads. Okay, so this I would say is a more relevant and a more appropriate term when it comes to tall buildings. Okay, so usually we will call a building as tall buildings when your lateral loads, which are the two lateral loads that we will have to consider for our tall structures, it is going to be wind and it is going to be seismic. Obviously there will be other loads also, there can be some snow loads or other effects, but mainly we will be sticking to the wind and seismic effects. So a tall building, when the lateral loads start to dominate, is we call a building as a tall building when the lateral loads start to dominate. One more definition will be that the dynamic loads start to dominate as compared to your static loads. So not just not just lateral loads, but we have to also consider the dynamic effects of lateral loads. I hope you understand what do I mean by dynamic effects of lateral load. So by dynamic effects of lateral load, I mean that not just static, but the overall stiffness and flexibility of your structure also becomes very important, and the time variation of these lateral loads also becomes very important. Okay, so when this happens in a structure, then we call that the building is, then we can sort of say that the building is tall. All right, so this is the most relevant and appropriate definition that I can think of. Now there is a council which is called as Council on Tall Buildings and Urban Habitat, which is called as CTBUH. So it says that usually buildings, so it makes for some further classifications, and it says that up to 300 meters it calls your buildings as tall buildings. Okay, then between, I mean, more than 300 and lesser than 600, it calls them as, I don't know what. Yeah, super tall. So up to between 300 and 600, if you have a building, it will call them as super tall, and more than 600, it usually calls them as mega tall. Okay, so this is a definition that has been put forth, or not definition, classification that has been put forth by Council on Tall Buildings and Urban Habitat, CTBUH. You must visit their website. It is quite informative, and it gives you a lot of data about the tall buildings that are there in different countries right now. It also gives you a lot of data about what are the structural systems that were used, who were the structural designers, who were the architects, some pictures, etc., etc. So you may be interested in visiting their website also. So important for us will be that we will call a building as tall when lateral loads will begin to dominate, and not just lateral loads, but the dynamic effects of lateral loads will begin to dominate. That is when we will call them as tall buildings. And how are they different then? We have understood what are tall buildings, but then how are they different? So because the tall buildings are governed by lateral loads, we have to think about the proportioning, about the uh, load resisting systems for gravity and lateral. We have to think about analysis and design of different elements in a different way than the regular buildings. So not just like regular buildings we do the design, but in tall buildings we have to think of some additional issues that may be faced by your tall buildings, and those additional issues, as I told you, are mainly due to the lateral loads and due to the dynamic effects of lateral loads. So because of this, we have to think about the load resisting systems, about the substructural systems, about analysis and design aspects in a slightly different manner than your regular building. Okay, so if this is a regular building, this is a tall building, I have to consider a lot of additional effects, and I have to keep in mind a lot of different issues when I do a tall building. Okay, so mostly when we are doing any regular structure, it is the strength design that is more important, isn't it? By strength design, I mean how much stress levels we can permit, what size we have to provide so that the load is effectively taken. So on that basis, we decide the sizes, reinforcement, etc. So generally, it's the strength design in regular buildings that is important. But when it comes to tall buildings, the flexibility and stiffness of your structure may sometimes take precedence over the strength design. That means that sometimes you may have to provide sizes just to satisfy some issues related to, let's say, floor acceleration, or issues related to drifts, displacements, etc. So therefore I am saying that the flexibility and stiffness design may take precedence over the strength aspect of your design. And as I told you, in regular buildings, the dynamic effects will become more important, and they have to be carefully evaluated and considered. How are they different? How are tall buildings different? So you may have to think about materials that are having greater strength, materials that have different properties, and materials that can that can be used for easier and quicker construction techniques. Those types of materials you may have to think about. So for example, concrete, we may have to use higher grades. So it's quite usual to see not just M40, M50, M60, M70, and so on, high strength grade concretes being used. You may see a lot of self compacting concretes being used in these types of structures, because uh, because of the large reinforcement congestion that you may get in those sizes. So you may see a lot of reinforcement congestion as well. Just give me a minute, I'll be back. Yeah, so I was telling you that you may have to use high strength concrete as well sometimes. You may have to use self compacting concrete due to large congestion in your sections of tall buildings. So, materials of greater strength, materials which suit your construction methods, construction techniques, may have to be used in these types of buildings. And yeah, so tall building construction may also require may require innovative use of construction methods that may not be used for regular buildings. So, in this manner, also you can say that a tall building may be different from a regular building. Okay, why we may have to think of innovative and different construction techniques? Because time is of great premium. If you have to construct a 80-story tower, you have to obviously come up with construction techniques that are easy, that are repeatable, that are quick. So these types of construction techniques also may have to be thought when you are doing these tall buildings. Okay. So in this manner, I will say that when we have to think about tall buildings, there are differences. Now, what is happening in India? Before going to India, I would say the construction of tall buildings has been going on in the United States for almost, I would say, around past 125 years. So, when was the Empire State Building constructed? Empire State Building, anyone? Empire State Building, if you have heard about. So, Empire State Building, which is what, around 100 stories plus. So, that was constructed in which year? Anyone in the live audience, if they can tell us? So, as far as I remember, your Empire State Building in Manhattan, New York, was constructed in Empire State Building was constructed, I guess, in 1931. No, no, not in 90s. 1931, almost 100 years ago. Okay, Empire State Building, 100-story tall structure, was constructed in New York, Manhattan, New York, in 1931. Before that, you had a, I don't know if you have heard, there was a building which is still there. Empire State Building is still there. There is a Chrysler building in New York, in Manhattan, New York, which was also, I guess, constructed sometimes in 1930s. Okay, so for 12 or 14 months, it was the tallest building, Chrysler, and then the Empire State Building took over. it became the tallest. And the Empire State Building was, I guess, the tallest structure for around 30-40 years, till these came up. Your World Trade Center towers in Manhattan, New York, came up. Okay, so then they became the tallest. They became the tall buildings. Then you had your Sears Towers in Chicago, which became the taller building. So in this manner, your tall building construction has been going on in America for almost last 125 years. But now, if you see, it has shifted the trend of building tall. Uh, yeah, Mr. Janmesh is providing us some data over here. So Empire State Building 1931, and Chrysler was in 1928, completed in 28. Good. So for 2 years, it was the tallest building uh, in the world, and then it was taken over by Empire State Building in 31. And then Empire State Building was the tallest building for almost 4 decades when it was taken over by the World Trade Center. But now the trend has been shifted. If you can see, the trend of building tall has shifted to China, Southeast Asia, and the West Asian Gulf countries. So all of us know that the tallest building now is in Dubai. Okay, Burj Khalifa is the tallest building, almost surpassing the previous tall building by, I guess, almost 1.6 times taller than the previous tall building. So it is around 800 meters, Burj Khalifa, isn't it? So now this trend of building tall has shifted to other countries, other regions of the world, other than US or outside the Americas, I would say. And in the 5-10 years, mostly post pandemic years, you are seeing lots of tall buildings being constructed in India also. When I say tall buildings in Indian context, it will be, let's say, up to 300 meters. So 200, 250 or 220 meters is usually what is the average story height you would get in the Indian context as of now. So 220 meters will be roughly how many floors? 220 meters will be roughly how many floors? So maybe, let's say, considering 3 meter, 3.2 meters for each floor, you can say around 70 to 80 stories buildings. I hope you get it. Okay. So 70-80 story buildings is what we will call as tall buildings here in India, because beyond that, beyond beyond 220 to 50 meters, more than that, the economic viability of such structures comes under economic viability of doing such a project becomes slightly questionable in the Indian context right now. Okay. Anyway, tall buildings are not economically viable usually. So if you see Burj Khalifa, it's not making money. Burj Khalifa, many offices, many spaces in Burj Khalifa still remain empty. Okay. So because of Burj Khalifa, Dubai as a whole makes money, but the building in itself is not making money. You might have heard that the during construction the developer got bankrupt and it had to be bailed out by a UAE developer. That's how the name Burj Khalifa was then given to it, isn't it? Earlier the name was supposed to be something different, but then it was bailed out by the uh, it was bailed out by the other emirate. I mean, Dubai is one of the emirates. It was bailed out by Abu Dhabi, I guess. Yeah, so Abu Dhabi bailed it out, or some other emirate bailed it out, and that's how the Burj Khalifa name was given to it eventually. So tall buildings in itself are not always economically viable. In India, as I was telling you, 220, 250 meters is is okay, is economically viable. If you bring a project of 220, 250 meters, it is economically, it will pay you back. So you will see more and more of these buildings these days coming up. Okay. Yeah, Mr. Janmesh is saying 210-meter building will go to around 50 to 60 stories, because there you will have to provide for the podium levels, you will have to provide for the parking levels. And after that you will have your residential apartment floors, so around 60 stories, let's say, and of course there will be some mechanical floors, etc., etc. So it will go to around 60 stories maybe. Okay. Yes, Mr. Arbaz is adding that even the Creek Tower and the Jeddah Tower are on hold. So Jeddah Tower, you might have heard, is what, 1.6 kilometers, if I remember. Yeah, 1.6. I mean 1600-meter tall building, Jeddah Tower in Saudi Arabia. So it was on hold for a few years, but last I was checking just last week, I the construction has restarted for Jeddah Tower, that is. And then I was also looking in Riyadh, they are planning to come up with a 2 kilometer tall building. So yeah. So anyway, so tall building you may build because of high human ego, but as a developer you also have to think about the overall project viability. Okay. So in India, you will see more and more of these 220 to 250-meter buildings coming up. I don't see India building a 700 or 800-meter tall building anytime soon. Maybe 300, 350. We will build more of these buildings in the coming future. And mainly you will see the thrust of building tall. uh, you will see the thrust of building tall mainly in cities, big cities like Mumbai or Bengaluru or Hyderabad, or the national capital region around Delhi. Delhi, I don't see many tall buildings right now, also because of the seismic problems in Delhi that you have. But in Mumbai, Bengaluru, Hyderabad, you see more and more of tall buildings being constructed. Obviously, Bengaluru is very good when it comes to building tall, because you don't have a lot of wind speeds over there. The basic wind speed I think is 33 meter per second in Bengaluru. The you get very good strata, the Deccan trap, all the Deccan basaltic rock you get in Bengaluru. So at shallower depths you will get very good hard strata. In Hyderabad also you will get good hard strata because of the Deccan. And wind speeds in Hyderabad are, I guess, if I remember, are higher than Bengaluru. In Mumbai, yeah, Mumbai you will get good strata, but then wind speeds are considerably higher when it comes to Mumbai. And NCR, I don't see right now the thrust, too much thrust in NCR. In Gurgaon, you may see construction for tall structures, but mainly 40, 50, 40, 50 stories. Not very tall because obviously it is in high seismic zone. Uh, so yeah, Sitaramji is saying tall buildings can create sinking problems in some cases. Yeah, if not handled properly, they may create some sinking problems. For example, there was a building in, I was reading about a structure in San Francisco, California, USA, which was around 60, 70 story tall residential building. And after construction, it started sinking. And just like Leaning Tower of Pisa, it started tilting also. So then they had to undergo major renovations, repairs, retrofit to save that building. In fact, even if you see in the American context, where do you see most of the tall buildings? In USA also, where do you see most of the tall buildings? Tell me. So most of the tall buildings you will see will be in what, in Chicago, and it will be New York. Okay, most of the super tall, not super tall, most of the very tall structures will be in Chicago and New York. Now these areas are seismically not very active areas. So these are one of the lowest seismically active areas in Americas. Okay, you will not see a lot of tall buildings coming up on the west coast of USA, that is in California or Seattle or San Francisco. I mean, in these western portions, you will not see in the state of California, in San Francisco or San Jose, or in the state of Washington at Seattle, etc. On the west coast, you won't see Lot of tall buildings. You will see tall buildings 60, 70, 80 stories, but not many of them. Why? Because they are seismically active zones. West coast of USA is one of the seismically most active zones in the world. Okay, so there are some live faults over there, and there is always a probability of big earthquake striking. So you have got that fault line right from Andes to the uh, Andes to Alps. No, not Alps. What do you call in this Rocky Mountains to Andes? You have a lot of fault lines over there. So I was telling you in NCR you may not see a lot of thrust, but in coming years and right now there is a lot of high tall structures coming up in Mumbai, Bengaluru, Hyderabad, and mainly the construction is happening in RCC, reinforced cement concrete. Uh, Still, you don't see a lot of steel construction, structural steel tall buildings being built in India as of now. So mostly, when it comes to residential apartments, when it comes to residential buildings, you will see the shuttering, Maiwan shuttering being used, Maiwan systems being used more and more in India. Okay, I hope many of you have heard about the Maiwan shuttering systems. So you people or the developers are constructing residential tall buildings in India using the Maiwan techniques. The commercial buildings in India are mostly your shear walls, distributed shear walls, plus columns, those types of structures. But what I wanted to tell you that they are mostly happening in RCC. Structural steel tall building, uh, as of now, is not very common in India, mostly because of the price differential, and because in India we have got cheap labor, so does not make a lot of sense to go for steel buildings in India as of now, isn't it? RCC makes a lot of economic sense in our country, mostly mainly because of the availability of cheap labor that we have. So, for example, if you see the Empire State Building, or if you see even the Sears Tower in Chicago, or the Empire State Building, or if you see even the World Trade Center, all those were structural steel buildings, isn't it? All those were mainly structural steel tall buildings. But so in the 1930s, 19 to 1960s, 1970s, there was a trend of uh, making tall buildings in structural steel, mainly in the Americas I'm talking about. But now if you see even in the American context, or even if you see in other countries like Middle East, West Asian countries or China, they are making more and more RCC tall buildings. Why? Because with development in material, with improvement in the material, we are able to create taller buildings because of the stronger materials that we have. Okay. Yes, Mr. Janmesh is right that you may think about composite columns integrating steel sections inside the concrete columns. Composite columns you may think of, but in very few projects in India. Yeah, I agree. Good, good. So mostly it is the RCC tall buildings that are being constructed in India, and obviously with ever increasing urban population, limited land, vertically going up will only be the way that will be seen in the future. You will have to go up and up, mostly in the urban centers. Vertical development is only the way. Now, this is what is happening, but then what is happening with us, the engineers? So, in spite of all this importance and prevalence of tall buildings and of RCC tall buildings coming up in, so now I'm coming to the engineering context, what is happening with the practicing engineers and students also, that a subject such as tall building design is uh, not covered in the syllabus, engineering syllabus. Obviously I don't expect it to be covered in the undergraduate studies, but even in the postgraduate studies it's not being given a lot of importance and emphasis. There are subjects of tall structures, but they don't teach tall structures. They are just I don't know what they are doing. I have seen some colleges where they have a subject in their postgraduate curriculum on tall buildings, but they are not covering tall buildings as such. They will just cover some, or they will just do a code reading, or I don't know what. But tall buildings are not being covered in the studies. So most of the times, as structural engineers, we are forced to learn on our own or on the job. And uh, because of this, because of lack of exposure, many times in recruitment also, or in the work also, practicing engineers may face difficulties. So if you see these days, more and more companies, more and more structural engineering consultancy firms ask for whether or not you have got relevant experience of doing tall buildings, etc., etc. So practicing engineers, working professionals like us, undergraduate, postgraduate students face difficulty because we have never come across these topics and we don't know how to address them. So that is why, and now I come to this, why we are going to start this course, because it provides, this course will aim to provide a platform to have an in-depth understanding about the different design and detailing aspects of RCC tall buildings. Through this course, we intend to explain and discuss the behavior of a tall building and the interaction of various elements of tall buildings, and we will go in depth in understanding a lot of different issues, a lot of different lateral load resisting systems that are adopted. So through this course, we will try to have very engaging discussions about these. In this course, so I'm telling you why this course, why we thought such a course should be conducted. So through this course, we also are looking to explain and discuss the special analysis requirements that we may have to do sometimes for these types of tall buildings, and how to obviously implement them in the software. And through this course, we will also have a wide discussion, clause wise discussion on the prescriptive code that you have on RCC, tall buildings in the Indian context. And then towards the end, we will take up an actual building. It will be a multi tower podium project, and we will try to do it as it would be done in your offices or in your actual project. How to think about an actual project on tall buildings, that also we will discuss. So through this course, we are intending to address all these issues. Before I go to the syllabus, a quick few things about us. Many of you know about us. So we have our consultancy, structural consultancy firm also, where we are dealing with a lot of different projects. And through this platform Oxen, we are into the training and skill development since 2015. And through our consultancy firm, we are involved in doing a lot of different types of projects: industrial, commercial, residential, infrastructural, some unique bridge projects, etc., etc. And since 2015, we have been conducting these skill development training sessions for practicing engineers, working professionals. So earlier we were all online, offline, sorry. So we used to conduct physical trainings, and now we have moved to doing completely online sessions post pandemic. And this is the list of all the courses, online courses, that we have covered in the past, and we have always got good response from our participants have been usually from all across India and from West Asian countries, Southeast Asian countries, East European countries. So a lot of different countries participants have joined us in the past also. And yes, we are always overwhelmed by the great response that participants have shown, and it is only due to their love and affection that we continue to conduct such courses. So this tall building course, I would say, is only possible because of all of you, because many of you have been telling us to conduct such type of a course, and many of you have helped us also in this course in creating content for this course. So I would be thanking them later, but yeah. So because of you, we continue to take such courses on interesting topics, and on topics that are important for practicing engineers and working professionals and faculty members, undergraduate students, postgraduate students like us. So, over the past several years, what we have understood that as a structural engineer, we require a strong theoretical base along with software proficiency, and we also require the experience of doing actual projects. So, as a practicing engineer, you just not be good at theoretical concepts, but you should be able to do them in practice. You may not just be good at doing projects, but you need to have a theoretical base also. So, both these aspects are important. And to address these, we have a two pronged approach where some courses we call them as our short term courses. They are not short as such, they are long enough, but we like to call them as short term courses where we try to build on the theoretical base along with software proficiency, and where we go in depth in understanding a particular topic. Okay, so out of the 20 odd courses that we have conducted, almost 11 are still available right now to be taken as self-paced courses. This is not what I wanted to tell you. Yeah, this is what I wanted to tell you, that all these short-term courses range for almost 60 to 90 hours. So we are able to go in depth for a particular topic that we intend to cover in these short-term courses. And then we have project design courses where we do some actual projects. So this is less on theory and more on how an actual project is done in the design office. So we have done three such project design courses in the past, and a couple of years ago we had done long term 6 months structural design center programs also in the past. So this has been our evolution, uh, and this is how we are moving ahead. And uh, through our courses we have been able to create a positive impact for our learners, and through our courses we try to address different issues. So we try to address the conceptual understanding, we try to help the participants in elevating or in improving their software proficiency. uh, Through our courses the participants are able to understand the Indian codes, not just Indian codes, international codes also, in a better way. Through our courses, participants have told us that even their performance at their workplaces improved, or in their own consultancy it improved. And our courses have also helped our participants in the job search. And participants who are postgraduate students, our courses have helped them in their studies also. Generally, undergraduate students who are appearing for engineering, they don't join our courses because we like to go in depth. So mostly it will be students who are, let's say, appearing for their masters or preparing for, I mean, who are undergoing their MTech studies, etc. The MTech and above, mostly participants like to join, or if you're or working professionals practicing engineers. Very good. So a few things about us. This is me on the right side, and I have done my engineering in 2009 from JSITS Indore and MTech from IIT Roorkee in 2011. And on your left side is Akanksha, my wife, and my classmate at IIT. That is how we had met. And she is also associated in our structural engineering consultancy firm and at Oxen. Both of us have had experiences of working in uh, big multinational companies in the past, and for 9 10 years we have been working on our own. Very good. So now we come to the main part. We come to the syllabus or the topics that we are going to cover. I hope you can see the screen. Okay, so we have gone to 50 minutes. I'll take maybe 10 more minutes before we finish off. No, 15 more minutes I'll take before we finish off the session, and then we will have your Q&A. You are able to see the screen, right? Okay. So how we will proceed with this course? So we'll start with what are tall buildings, and we will have a look at the historical development of tall buildings. It is important to look at the historical development because that is how we will understand how the concept of tall buildings have evolved over the past, let's say, 100 years, how it has evolved. We will have a look at that. Then, very important, we will go to understanding the different systems that are adopted. So we will start with the gravity load resisting system. So as I told you, in any building, mostly in tall buildings, but you will have your gravity loads that have to be resisted, and you will have your lateral loads that have to be resisted. In tall buildings, resisting your lateral load becomes more important than resisting the gravity load. So you have to come up with innovative systems to resist tall buildings, to resist lateral loads in tall buildings. So gravity load resisting systems are simple, not very difficult. But when it comes to understanding different types of lateral load resisting systems, it will be important for us, and we would like to discuss these systems not just theoretically but through some practice models in ETABS. I will be dealing with all these systems. We'll try and see their behavior, how each and every system is behaving. We'll make some actual ETABS model for these types of systems and try and see how they behave. Okay. So in this development of these systems, I don't know if you have heard about Dr. Fazlur Khan. He Have you heard about him? So he is a big name when it comes to tall buildings, and he played a significant role in developing some very important conceptual systems, mainly the tube and tube system, the bundle tube system. He played a very very important role in its development. I don't know if you have heard about him. So he was born in undivided India sometimes in 1929. Okay. And in 47 it got partitioned into East Pakistan. So but he was born in undivided India. He did his BE from uh, IISCT Shibpur, Calcutta. That is, Shibpur is in Calcutta, right? Near to Calcutta. So that was before partition when he did his engineering from Shibpur, and then he went on to US. Then he went on to US where he did his masters and PhD and whatnot, and then he started working at SOM, Skidmore, Owings and Merrill. It's a very famous company which specializes in tall design, structural design, architectural design. So then he joined SOM, and there he developed all these different types of lateral load resisting systems. So mainly he can be credited with the development of tube systems, or the tube and tube system, or the bundled tube system. These systems were mainly developed by him during his time at SOM. So Dr. Fazlur Khan has got an Indian connection also. I think some of you have done some studies from Shibpur, isn't it? IICT. Yeah, so you can be proud about your alumni who became a stellar engineer in the field of tall buildings. Right. So I'll be talking more about this when we discuss these different types of lateral load resisting systems. Then we will go to the gravity load calculations for tall buildings. That will be not very difficult. Then we will go to the lateral loads. So lateral loads will be important for us because lateral loads will play an important part. And in lateral load also, wind loads are usually the more critical of the two lateral loads. So this is what we will be dealing with. And in wind load calculation, we'll be looking into the calculation of wind parameters, static wind forces. Give me a minute. Yeah. So in wind load calculation, as I was telling you, first of the lateral loads where we will put a lot of emphasis on. So we'll see how to calculate your wind parameters, static wind forces. Then we'll talk about the dynamic wind force calculation, the gust factor calculation, how to calculate the along wind and across wind loads, how to calculate the floor accelerations. All these things we will do. Then we will see and have discussions on how the wind tunnel testing is carried out. Obviously, we will not carry out wind tunnel testing, but we will discuss the concepts behind the wind tunnel testing. We will also discuss what type of outputs are obtained. If a wind tunnel testing consultancy is giving you some output, what type of output they give you, and how you apply those outputs as inputs on your structural models, that also we'll discuss. Then we will go to the seismic load calculation, the another important lateral load. In this we will see the general seismic parameters, how to calculate, how to understand. We will have a look at the equivalent static method and the response spectrum method. We'll not be going too much into non-linear methods. We'll not be going too much into time histories. We'll stick to response spectrum method at best. And then we will have some theoretical discussions also on the performance based design, because when your structure does not follow the codal prescriptive limits or the codal prescriptions, you may have to show by performance based design that your structure is going to behave in an intended manner, showing acceptable performance levels. So for that, usually we have to go for performance based design when your building may not follow the codal prescriptions. So we'll have a discussion. We'll not do a lot of numerical calculations for this, but we'll have a discussion through some international documents. Then we will have a clause by clause discussion on the code IS 16700 2023. We'll have a clause by clause discussion on this. We'll understand and discuss all these clauses. Then we will have a discussion, and we will be doing it on ETABS about the analysis requirements, special analysis requirements that you have to have or that you need to do for tall buildings. Mostly they are the backstay effects, the effect of podiums, and how the shear reversal takes place when your podium slab is connected integrally with your towers, and how to understand these backstay effects, how to understand that shear reversal effects, what is the meaning of sensitivity analysis. Not very difficult, but we'll do that. Construction stage analysis, what's the importance of construction stage analysis, why it is important, how you can do it, that we will discuss. Then we will have discussions about the effects of axial shortening of vertical members. So in stall structures, what will happen, that under dead load itself, not even before live load, just under dead load itself, there are tendencies that columns undergo axial shortening. Okay, the problem is that when there is a differential shortening, that means some vertical members are going undergoing axial shortening, some of them are not. Then things start to become complicated. So this we will discuss. I would like to say over here that this axial shortening or the importance of construction stage analysis generally will be seen, let's say, buildings which are 250, 300 meters and more. Okay, so as I was telling you, for in the Indian context right now, what's happening, we are constructing more of, let's say, around 200 220 maybe 250-meter buildings. So in these cases, you may not be seeing a lot of these effects for axial shortening, or you may not see the importance of construction stage analysis in structures up to 200 meters. When you start going beyond 300, when you start entering into the super tall, mega tall region, that's when all these effects start becoming extremely critical and crucial. Also, for this horizontal acceleration, drifts and displacements anyway will obviously like to control, but when it comes to the horizontal accelerations of floor levels, uh, it becomes important, and it needs to be carefully looked into. This also starts becoming critical when your building height goes more than 300 meters. When I say building height goes more than 300 meters, I also should add the aspect ratio for it. Okay. So when your what do I mean by aspect ratio? Aspect ratio would mean that in plan, if this is B and D, let's say, and in elevation, this is my height. So h upon B or h upon D will be the aspect ratio. So when your aspect ratios start going to, let's say, 7, 8, 9, and so on, okay, then this horizontal acceleration or the effects of dynamic loads start becoming more and more critical. Okay. Yeah, 300 meters has been completed in Mumbai, but 300 meters in Mumbai has an aspect ratio of only 4. Okay, so that means it is 300 meters in height. The height is 300 meters, but its plan width is, I think, some 90 or 86 meters. The Palais Royal in Mumbai, done by Sterling Consultancy. So its plan size is 90, isn't it? Its height is 300, but plan size is 90 by 90, or it's a oval shape actually. So it has a very low aspect ratio. So even though the height is tall, but because of such a huge plan size and because of such a low aspect ratio, these problems of horizontal acceleration or drift displacement, these problems are not seen over there. You get my point? So not just tall buildings, but what is the aspect ratio, that also becomes important. I don't know if you have heard about this. What is it called? Steinway Towers in Manhattan. Very, very slim building. I don't know if you have seen it. I'll just search the name. Yeah, Steinway Tower. Steinway Tower. Steinway Tower is having an aspect ratio of 24. Aspect ratio of 24. It is having a height of around 470 odd meters, and compared to that, its plan size is only 50 or 60 feet. It's built on a very small plot size of, I guess, 40 feet by 40 feet or 50 feet by 50 feet. I mean, on which you will build your bungalow on such a small plot size. They have constructed a 470-meter tall building. So it's a very, very thin looking tower having a aspect ratio of 24, which I think is the highest in the world right now, highest aspect ratio in the world right now. And because of this, there are lots of issues which they had to uh, mitigate, and they also had to go for damping systems. So I think they have gone for a tuned mass damping system on their building, because otherwise you will not be able to control the horizontal accelerations, you will not be able to control the drifts and displacements for such a high aspect ratio. So when your aspect ratio is 7 8 6 7 8 in this region, you don't have to be very, very worried about these issues. But when you start entering into an aspect ratio of 12, 13, 14, and so on, then these issues like horizontal acceleration, then the issues like across wind response, they're becoming more and more critical. Anyway, we'll discuss all these issues in detail during the course. So once we do the special analysis requirement, then we will go for the design and detailing of different elements of tall building. So we will discuss about the design and detailing of beams, columns. Will will discuss important issues related to diaphragms. Diaphragms are nothing but your horizontal slabs. So we'll like to discuss issues related to design of diaphragms, about cords and collector elements, how you ensure that the load is properly flowing through your horizontal system and is getting properly transferred to your vertical system. So through cords and collectors, we do that work. So we'll look into the design of these elements. We'll also look into design of special elements like transfer slabs or transfer girders if you have, although not very recommended, but it's a reality that you have to do. So we'll discuss about this also. Then we'll do discussion on columns, shear walls, and when you have got coupled shear walls, or when you have got shear walls where you have to leave openings, then you have to think about the spandrels, etc. When you are going for coupled shear walls, you have to uh, think about the coupling beams also. So this also will discuss basement walls, because we'll be doing a project which will have basement. And for substructural system, we will take up raft and raft plus pile. So this also will end up discussing. And in the end, we will take one sample project, which will be a multi-tower project with a common podium slab and parking levels. So this, and it will be a G plus 50 story type of a building which we will be doing. So when I say we will be doing this project, I don't mean that we'll be calculating each and every reinforcement, and we'll be calculating each and every column reinforcement, we'll be doing each and every beam reinforcement, but we'll be discussing how you will do such kind of project. We'll make models on ETABS, we'll apply loads and all those things, but detailed design, uh, making construction drawings, those things will not be doing, because those things you can understand and do on your own also. But I'll be focusing more on how to make such models, how to plan the lateral load resisting system, how to provide all those elements, how to do the analysis, how to do the checks, everything. Those types of things I'll be more interested in doing in this sample project. We'll not be doing the BOQ calculation, or we'll not be doing the calculation for each and every column beam reinforcement, make the reinforcement drawings. That type of work will not do. That type of work, I guess, all of you are uh, capable enough of doing. I'll like to discuss more on the technical aspects of such type of a project that we'll be doing. And obviously, yeah, we will be doing the how to calculate the cord and collector reinforcement, how to provide them. Yes, we'll be doing that. And where this becomes important, that we'll discuss. And the standards that we'll be referring to are the parent Indian standard, the concrete standard. Amendment 6 has been issued. Amendment 6 issued on 24th June 2024. IS 456 amendment. I guess it was just issued last week. No, this week itself it was issued. No, last week. Last week it was issued, and it is available now. You can have a look. I thought they are going to revise IS 456, but now if they have brought out an amendment, I don't know when they are going to bring the revised 456. Anyway, we'll be obviously having a look at these codes. 875 part 3, obviously, IS 1893 13920, and for a few things we may also have to go to ASC 7, which is the American code for load calculations. And we will be doing these discussions on ETABS and SAFE, not on Stat Pro, please. ETABS and SAFE, and time to time we'll like to refer to AutoCAD, MS Excel, etc. Yeah. So our live sessions for this course, our live the live sessions on this course will be conducted between 8:30 a.m. Indian Standard Time to 10:30 a.m. Monday to Friday. And because many of you are going to be working professionals or practicing engineers, you can also join our course as self-paced learning course. That means You can watch the sessions later on our portal as per your convenience, because many of our participants, as I just said, are practicing engineers, so they don't get time to attend the sessions live. So there is always this option to join the course as self-paced learning course, and we will give you a 1 year validity to watch the sessions on our portal. We will be taking up live examples of relevant cases, doubt solving sessions, yes, and on completion we'll give you e-certificate, yes. Now, who will benefit from the course? So generally postgraduate students who have done post graduation in civil structural engineering, or young structural engineers who are searching for job or working, wanting to start up as consultants on their own, or engineers who are looking to deep dive into this topic of tall buildings. Experienced engineers, senior engineers who are looking to explore tall buildings will be benefited from this course. And obviously, anyone in general who loves structural engineering would like to join this very interesting course that we are going to begin with. It's very important to understand what will be the course outcome, and I'm sure once we complete the course, we would have met these outcomes. So by the end of this course, we expect that the participant will develop an in-depth understanding of the general behavior of tall buildings and what are the various systems that need to be adopted for tall buildings. I hope participant will develop this understanding. By the end of this course, the participant will be able to calculate and do different analysis and satisfy different analysis requirements for tall buildings, and be able to do it on softwares like ETABS, etc. The participant will be able to carry out design and detailing of various elements of tall building on their own. This is what we expect at the end of the course, the outcome will be. And all these learnings, we expect that the participant will be able to apply for an actual project also, because we will also be taking an actual project in which we will be we will be applying these learnings. So how to proceed ahead? So if you want to join, the course fees is rupees 6750 Indian rupees. We like to keep the course fees low, mostly underpriced, because we want that many more participants should join. So that's why generally we like to keep our course fees low. The method and payment will share you how to do the transfer. I'll share you later on separately. And then once you join, we will add you to another course WhatsApp group where you will get the updates and links for daily sessions. And we'll be starting our course from Monday, 15th of July 2024. Obviously, this date will be important for those who are looking to join live sessions. Those who are looking to join the course as self-paced course, any day after 15th of July, you will be able to watch the sessions. Obviously, live session will be uploaded on the same day. So in that sequence of what we, I mean, in the sequence we conduct the live sessions, you will get to watch the sessions on our portal also. So before I take up questions and queries from the audience, a few frequently asked questions and their answers. So as I told you, many of our participants are working professionals. So if they want to join, or practicing engineers or faculty members, if they want to join, how they can join the course. So if you are unable to attend the live sessions, as I explained, you can join the course as self-paced course, where you can watch the sessions at your own convenience, and every session will be uploaded online on our portal within couple of hours of conducting it. So then you will be able to watch those sessions. And those who are joining the session as self-paced course, we usually try to address their queries through chats or messages or through our course WhatsApp groups, or if required, we can have some we can arrange for some interactive sessions also for them. Okay, so this is what we have been usually doing. I am new to RCC design. I don't know anything about RCC design. Can I join? I would say no. This course is not for you then. If you are new to RCC design, you should not join this course, because we are looking to focus on the issues and aspects of tall buildings. So where we expect that the participant understands the basics of RCC design detailing, we expect the participant to understand the basics of earthquake load calculations, the basics of wind load calculations, a few basic things about footings, foundations. So if you are new to all these things, I would suggest you not to join this course, because then you will not be able to uh, do justice with your time, effort, and money. So I would say only join if you have a basic level of comfort doing RCC design and detailing on your own. But then we always have an option for you. If you are new to RCC design, you can have a look at our courses that we have conducted, the basic course that we have conducted on RCC structures. You can have a look at the course that we have conducted on foundation systems and the earthquake resistant design and detailing for RCC structures. So if you are new to RCC design, you have a look at our other courses that we have conducted. Don't join this course. Okay. Yeah. So that's all that we had to discuss. Thank you for patiently listening. We shot up the time by almost 20-30 minutes. Anyway, yeah. So that's all. Now, queries from your side. So, any queries, anything what you want to ask? Mr. Milan is saying, I feel the sessions will be more focused on analysis and design. Yeah, so when see we would like to go in depth for tall buildings, not just take up a random 30-story building and do it. Not that way. That's not our way. We would like to go in depth about the different aspects of tall building. So we may be taking up a 50-story building, but I want you to be able to even do a taller building than that on your own. Okay, so that's what we would like to do. So therefore we would like to go in depth on each and every aspect of tall buildings. And in the project also, as I discussed, I like to focus more on analysis and design checks rather than calculating reinforcement from moments. Those things you can do, isn't it? If the moment value is known, you can easily uh, you can easily calculate the reinforcement on your own. Those types of discussions I think will not spend a lot of time on. Mr. Milan is saying, what will be the timings for discussion on doubts for self-paced courses? So, as I told you, generally we will make our course WhatsApp groups where you can ask your doubts, difficulties, queries, or you can ask on personal chats or messages. If there are a lot of doubts which are going unresolved, then we can plan for some live sessions on weekends, maybe for participants who are joining us, the course as self-paced course. Mr. Srinivas is saying, but morning everyone goes to office. That's why I told you that there will be an option to join the course as self-paced course. And as I also told you that many of our participants, because they are practicing engineers, they would like to they like to join our courses as self-paced courses. But the live session timing will be in the morning, because by evening everyone is sort of discharged. I don't think evening sessions are that effective. Although you get free from your office, you have time, but by evening everyone seems to be a little bit tired. So no live sessions in the evening. Live sessions will be in the morning, and but you can obviously join the session anyway as per your convenience later on also. Mr. Rohit is asking, can we increase the validity of the course? Yes, you can. Yes. Mr. Janmesh is saying, is the project, will it have flat slab systems till residential floor and then framing system till top? Many architects and develop insist on it for height restrictions and other practical issue. We'll see when we get to the project. Mostly it will be a framed structure, but we may explore the option of flat plates maybe for lower levels. We'll see. Mr. Magaji is saying, what are the checks we'll do for sensitive analysis? Sensitivity. See, you must understand sensitivity analysis just means it's not a term for tall buildings. Sensitivity analysis is a general term, which means that you change some parameters and you see the effect of changing those parameters on your values. So that is the basic meaning of sensitivity analysis. Okay. So when it comes to your backstay effects, I think you have seen that your code has given you some upper bound and lower bound stiffness modifiers. Okay. Code has given you upper bound and lower bound stiffness modifiers. So when I say sensitivity analysis, what it means that you try and vary those modifiers and then you try and see the output that you will get in your lateral load resisting systems, the type of output that you get in your slabs, podium slabs, etc. And then depending on those different outputs that you are getting for these values between upper bound and lower bound, you take whichever is the highest value, and that highest value you use for your design. So when I say sensitivity analysis, it's a general term which means that you vary certain parameters, you get outputs, different outputs, and you take up the highest output that you're getting and use that for your design. That is the general meaning of sensitivity analysis, where it is used in tall buildings, mostly in the backstay effect. And we have been given a range of modifiers, upper bound, lower bound values. So we try and vary the modifiers to see the output. That type of calculation will be called as sensitivity analysis. Mr. Nandu Prasad is saying, do we have PT slab in this course? No, we will not be dealing with PT. Although in structures you may have horizontal systems which have PTs in them, but due to the restriction of what we can cover in this course, we will not be covering PT. Very good. Anything else? Any other query, doubt, difficulty you have? Okay then. So I guess that is all that we have. Uh, I'm very excited about the course that we are going to soon start. Mr. Milan is saying, if I have enrolled in a self-paced course, yeah, of course you can join the live session also, of course, uh, because we will be sharing the link for our live session on the WhatsApp group. So if you have time, you join the live session. If you don't have the time, don't join the live session. If you have only 1 hour, you join 1 hour, then you leave. Whatever. I mean, whatever you want to do, you can do. You can join live sessions also. Mr. Janmesh is asking, can we capture effect of PT? What is PT? Acha, you mean post tensioning or pre tensioning? That is what you mean? Prestress systems? That is what you mean by PT? Acha, you have written it in small, so I got confused that it is AST. Generally, percentage steel. Okay, yeah. So, in normal modeling, generally for stiffness calculations, we don't take the effects of PT usually. So, it is mostly for the strength calculations that we take the effect of PT. So I'm not sure whether we can capture the effect of PT in conventional modeling because I have limited knowledge on PT. So I don't know. I'm not the right person. But as far as I understand, usually these people, they don't do the calculations for stiffness or flexibility depending on the PT system. So they don't consider the effect of your PT systems for uh, stiffness calculations, only for strength. Mr. Mehul is asking, how are water pressure managed in plumbing systems? You mean in tall buildings you want to say? So in tall buildings, usually all your plumbing systems will be done by pressure pump. So you won't be relying on gravity. You won't be relying on gravity. You will be relying a lot on pressure pumps to maintain water pressures. Not just water pressures, but when it comes to MEP services also, things become very interesting and difficult, especially in tall buildings. So when it comes to your HVAC systems, or when it comes to electrical systems, when it comes to your plumbing systems, maintaining pressures, maintaining proper air circulations, maintaining pressurization lift chambers, maintaining and ensuring you have got enough vertical transportation, lifts, etc. There are a lot of different systems that you have to incorporate in your tall buildings, like pressure pumps, or like distributed electrical circuits, or special mechanical floors at several intermediate levels, where all these services are provided in batches. There are lots and lots of issues. Yeah, service floors, that's what, mechanical floors or service floors that you have to provide at intermediate levels. So all these things we have to carefully look into for tall buildings. That's why I said that tall buildings in Indian context right now may not be economically viable beyond 80, 85 stories in the current scenario. Why? Because all these things start becoming the MEP components, uh, mainly the HVAC, or your vertical transportation lifts. All these big cladding systems, all these start becoming more and more expensive and costly, and even their maintenance costs start becoming very high. So it's not always economically viable to go beyond a certain height limit. But yes, MEP systems become extremely important in these types of structures. Mr. Srinivas is saying videos available for lifetime. So as I told you, initially we provide validity for 1 year, then we extend the validity for which we don't take any charges. So practically the validity is, I mean, nothing is lifetime as such. Who has seen your what happens in your life? But yeah, on theoretically you can say it lifetime. Initial validity will be 1 year, and uh, after 1 year, if you are still unable to complete the sessions, we increase the validity. For that, we generally, not generally, for that, we don't take any additional charges. But then, why don't we give lifetime access initially? Because then you will not watch the sessions. So, therefore, initial validity will give for 1 year. Damping systems will be there? No, will not be having any damping system in our building. Engineer Imran Khan is asking, can we do checks based on ASCE code? Yeah, for some checks we may have to go for ASCE, or the relevant clauses of even ACI, because not everything is clearly given in the Indian code. Sitaramji is asking, can we use bubble deck slabs in tall buildings? You may use in horizontal system whatever different system is available in the horizontal system. I mean, whatever different horizontal system is available, you may use. Nobody stops you from doing that. Yes, anything else? Any other query, question, doubt, difficulty? So I think that's all. We hope to see all of you join the course, and I can assure you that we will have a very engaging and a very interesting course. A lot of new things to learn for me, a lot of new things to learn for you also, and we'll have a good time in this course. That's all. Have a good weekend, and see you next week when we start with this course. Bye bye. Okay, there are more questions. Mr. Milan is saying, in high rise buildings, I have observed the air pressure release valves and RVPRV is being used for controlling the water. Yeah, that's what, correct. It has to be a pressurized system. It has to be a pressurized system for water transport. Can we see the effect of membrane and shell? I mean, you can, but that's very basic thing. We'll do it. Not a big thing. What books need to study to understand better? So I would suggest book by uh, Professor Taranath Bangali. I hope you all of you have heard about him, and it's a good book. It teaches you a lot. Uh, more on less on theoretical. I mean, less on the practical aspects, but lots and lots of discussion on the theoretical concepts, on the things that you need to understand for tall buildings. So, book by Professor Taranath Bangali, I guess, is a very good book. Then another book that I came across that I have been reading, and it's a very interesting book. Again, less on practical calculations, but more on the concepts, and that is designing. I'll just write. I'm writing the name. Designing tall buildings, structure as architecture. So very interesting concepts he has given. Designing tall buildings, how to imagine the structure itself behaving as the architecture of a tall building. This book is written by engineer Mark Sarkisian. I don't know how to pronounce it. And he was a director at, and I think partner at SOM. So he himself has been involved in a lot of tall buildings, design and detailing and conceptualization of tall buildings. He has himself been involved in that. He has written a very good book, very good way of writing, and gives you a lot of discussions on conceptual understanding. Uh, Very interesting book, must read. Book by Smith. I am not. Can you just elaborate name and etc.? Can you give the full name of the book and the name of author, full name of author? Okay, I'm not sure if we have the full name. Uh, will we be checking the effect of membrane and shell in terms of deflection, time period? These are very basic things. We'll do it. Not very. I mean, these things. I hope you'll be able to do it on your own also. Yes. So, book by Smith. I don't know what is the full name of Mr. Smith, or what is the full name of the book. Maybe we'll have to look it up on the internet. So, but these two books I have been reading, and I found them very interesting and a very good read. Just like a non-fiction book, also you can read these two books. Uh, Not like an engineering book as such. Yeah. Another book, Tall Building Structural Analysis and Design by Brian Stafford Smith and Alex Cowell, whatever. Okay, so this I didn't know. I'll look it up on the internet. Tall Building Structural Analysis and Design by Brian Stafford Smith and Alex Cole. Thanks for this information. Yes, so I guess that's all then. We hope to see you all next week when we start this course. Till then, have a good time, have a good weekend. Bye bye, and take care.